Okay, so in this lesson, we're going to continue talking about solving exponential equations, except this time we're going to use logarithms to solve exponential equations. Now, remember in the last lesson, we used like bases to solve exponential equations. Now, for example, when we solve this right here, let me get this. So when we solve this right here, we got the base to be 2. Remember that? The base was 2. Here the base was 5, and so on. All right, so when we did all these problems, we were able to get the bases to be the same. All right, so all the bases in these problems, we were able to get the same. When we had 5 to the 3x minus 6 equals 125, the base was 5 that we had to use. Okay? Now, the problem is, though, that in some situations, like if we had, let's say, 2 to the x equal 6, there's just no way that you can get the bases to be the same. No matter what you try, there's just no way that you can rewrite this with the same base. All right, so we got to solve this. This is still an exponential equation. The variable is located in the exponent, so we still have to solve this equation. And what we can do to solve this equation, since logarithms are functions, remember logarithms are functions, so since logarithms are functions, we can take the log of both sides. Okay, now let's go ahead, before we do this one, let's go ahead and do something like this. Suppose we had 3 to the x is equal to 27. 3 to the x equal 27. All right, now let's do this one using the like bases. So the base that we would rewrite this as would be 3. Okay, so I'm going to leave this as 3 to the x, and then 27 is 3 cubed, and so since the base is the same, remember we can use the one-to-one property of exponents. Since the base is the same, the exponents have the equal, so we get x equal 3. Okay, now let's look at the same problem. 3 to the x equal 27. Let me leave some space here. Right here. Alright, so I just left some space here. So we're going to do the same problem, but this time let's take the log of both sides, the log. Alright, the log of both sides. Now remember, if we're going to use the calculator, we need base 10 or base e. So if I'm going to take the log of both sides, I'm going to leave it as base 10. See, if I'm going to use the calculator. All right. Now remember the power rule. The power rule says that I can take this power here and rewrite as a product. So don't forget to do that. So I'm going to get x times the log of 3 equals the log of 27. Now remember, the whole idea was to solve for the variable x. Since the variable x is located in the exponent, we want to get rid of the variable that's in the exponent. We want to take it out of the exponent. One way to take it out of the exponent is to take the log of both sides. And then once you take the log of both sides, you can use the power rule for logarithms. So you can rewrite this as x times the log of 3. Okay, now, notice what happens. So to get the variable by itself, right now, I'm multiplying by the log of 3. The opposite is to divide by the log of 3, just like this. And so the log of 3's divide out. Log of 3 divided by log of 3 is 1. 1 times x is x, and so I get the log of 27 divided by the log of 3. Okay? Now, let's see what that equals to. Now, don't make the mistake. Again, we've talked about this before. So the logarithms here, that does not mean the log times 27, and that does not mean the log times 3. So this is read as a log of 27. The log of 3 of here is not an operation. Does not mean multiplication. All right, so the log is a function. You're taking the log of 27. That's a function. The log is a function. You're taking the log of 3. The log is a function. So again, don't even say 3 to 3 is 1, 3 to 27 is 9. You can't do that because that's not an operation multiplication here. Okay? So you need to be careful as you're going through, as you're working with logarithms. But what I want you to do next is to take the log of 27 in your calculator. So the log of 27, so log 27, close it, divide by, and then the log of 3, log 3, close, and notice what you get. You get 3. So the log of 27 divided by the log of 3 is 3. So x equals 3, which was what we said it was. Okay? Now, you see how I took the log of both sides? So I was using the common logarithm. Remember, this is a common logarithm. Common logarithm. So I'm taking the common logarithm of both sides. I'm taking the log of both sides. Remember, a common logarithm has base 10. I could have taken the natural logarithm of both sides. So I'm going to come right here and rewrite it. So 3 to the x equal 27. So remember, I can take the log of both sides regardless of the base. It does not matter. If all I'm trying to do is to remove the variable out of the exponent, then all I need to do is take the log of both sides. It does not matter what the base is as long as it's positive and not equal to 1. So I'm going to take the log of both sides with base e. Now remember, the log of both sides with base e is called the natural logarithm. So I'm going to take the natural log of both sides. And so now I'm going to use a power rule, because remember I'm trying to get the variable out of the exponent. So I'm going to use the power rule. So I'm going to rewrite this as x natural log of 3 equals natural log of 27. And so when I divide both sides by the natural log of 3, I get x to equal natural log of 27 divided by the natural log of 3. Now in your calculator, let's see what that is. So you can take the natural log of 27. This time you use the natural log. Remember, the natural log has base e, log base e. 27 divided by the natural log of 3. And notice what happens. Oops, I think I messed something up here. Natural log of 3. Alright, so, oops, I'm sorry. I did mess up. So I did multiplication. So the natural log of 27, divided by the natural log of 3. And I knew I had messed up because what do you think this is supposed to equal? Well, remember we said when we take the log of both sides, regardless of the base, the whole idea is to get the variable out of the exponent. So if I take the log of both sides, no matter what the base is, then x better equal what? X better equal 3. So let's see if we get 3. And notice we get 3. Okay? So x equal 3. Alright? Now over here, again, so basically this means that it does not matter whether you take the log of both sides, the common logarithm, or whether you use the natural logarithm. So whether you use take the log of both sides base 10 or take the log of both sides base e, it does not matter. Okay? The whole idea is to get the variable out of the exponent so you can solve for x. So over here, notice the variables in the exponent. I need to get this exponent, I need to get the variable out of the exponent so I can get x by itself. Well, remember, logarithms are exponents. So I'm just going to take the log of both sides, and let's just take the natural log. So I'm going to take the natural log of both sides. It does not matter. You can take the log both sides, a common logarithm, or you can use the natural logarithm. But the whole idea is to get this variable out of the exponent. So I get x, natural log of 2, equals natural log of 6. Then to get x by itself, right now I'm multiplying by the natural log of 2. So I'm going to divide by the natural log of 2. And so I get x to be approximately equal to, and the directions will say round to 2 decimal places. Now, let me just say this. In my math lab, they're going to ask you to express the answer in logarithms. So you're going to say x equal natural log of 6 divided by the natural log of 2. So that will be the answer for the part of the problem that says express using natural or logarithms. Express using logarithms. Now, they're also going to ask you to approximate this to 2 decimal places. So to 2 decimal places, let's see what that is. So I'm taking the natural log of 6 divided by the natural log of 2, close the parentheses, equal, and to 2 decimal places, that's 2.58. So that's approximately equal to 2.58. So 2 raised to the 2.58 is approximately equal to 6. Remember the original problem was this. Okay, so that was the original problem. So remember we said this is approximately equal to 2.58. Let's see if it's true. So I'm going to say 2 raised to the, so 2, I'm just checking, raised to the, and then we're saying it's about this, 2.58. Let's see what happens. Let's see what happens. Hopefully it's close to 6. I want this. It's not going to be exactly 6 because this is an approximation, but it better be close to 6. And notice it's close to 6, 5.98. Okay? Alright, so let's look at some problems. So the directions will say this. Directions will say, solve each exponential equation, express a solution in terms of natural logs or common logarithms, then use your calculator to obtain a decimal approximation to decimal places. So that's what we did here. So we expressed it as a natural logarithm, we expressed a solution as a natural logarithm, and then we used a calculator. Alright, so let's look at number 1. Okay, number 1. Suppose we had 10 to the x equals 4.23. 10 to the x equals 4.23. Now, remember, follow directions. If the direction says make sure you solve these using like bases, then you use like bases. There's no way that you can get these to be the same base. So then you have to take the log of both sides. Either the common logarithm or the natural logarithm. Now, here's the situation I want to show you. So I'm going to rewrite this again. Okay? And I want to show you something. I'm going to take the natural log of both sides over here. So remember, trying to solve for x, right? So the variable is located in the exponent. The only way you can get this variable out of the exponent is to take the logarithm of both sides. And so I'm going to go ahead and take the natural log. I want to show, and the reason I'm doing that is just to show you something when we do this one. Oops, I'm sorry, natural log. So the natural log of both sides. So natural log of this side, natural log of that side. Now I can use the power rule to rewrite this. So that's your next step. Make sure you show this. X natural log of 10 is equal to natural log of 4.23. And then you get x by itself. You can divide both sides by the natural log of 10, just like this. I'm going to go ahead and rewrite it. All right. So you can take the natural log of both. I'm sorry. You're gonna solve it for x. So right now you're multiplying x by a natural log of 10. So you can divide both sides by natural log of 10. All right. And so the natural log of 10 divided by the natural log of 10 is 1. So I get x equals. Now here's your solution in terms of natural logarithms. So that would be what you would write down for that part. Then your approximation, which is the next part, use your calculator. So then the approximation will be this. So you're going to take the natural log of 4.23 divided by the natural log of 10. Natural log of 10, close the parentheses, press equal, and so that's about 0.63. So 0.63, okay? All right, so remember, in order to use your calculator, you're going to either take the natural log of both sides, or you can take the common logarithm of both sides. So I'm going to go ahead and rewrite this, just like this, and I'm going to take the log of both sides, okay? Log of both sides. And so just like we did here, we're going to rewrite this. I'm going to take this exponent, I'm going to write it in front. So I get x times a log of 10 equals a log of 4.23. Now I want you to remember something. You know what the log of 10 is. So the log of 10. So the log, remember this base right here, there's no bases, it should be 10. That's why it's called a common logarithm, base 10. So 10 to what power is 10? So the answer is 1. So I want you to realize that this right here is 1. Right here, the log of 10 is 1. And so x times 1 is x. So all you're left with is x equals the log of 4.23. That's what x is. The log of 4.23. So that would be this part here. So express your solution in terms of, in this case, common logarithms. Now let's approximate this. So you would say the log of 4.23. Make sure you use the common logarithm. So the log of 4.23, close, press equal, and you get 0.63. All right. Now, let me go ahead and rewrite this part over. I want to discuss this next part. So we had x times the log of 10 equals a log of 4.23. Okay? All right, now let's suppose you did not remember that this was 1. All right, let's suppose you did not remember that. You did not remember that this was 1. All right, well, if you don't remember this is 1, then you still got to get x by itself, right? Just like we did this. So to get x by itself, right now, multiplying by the log of 10, what's the opposite? Well, the opposite would be to divide by the log of 10. All right, and again, you got to make sure you do the work just like this. Log of 10. So the log of 10 divided by log of 10 is 1. 1 times x is x. So in terms of logarithms, this would be my answer. So you'd say log of 4.23 divided by the log of 10. Okay? Now let's approximate this. So hopefully we'll get the same answer. Hopefully we'll get this. So let's see what happens. So this time we're going to take the common logarithm of 4.23, close the parentheses, divided by the log of 10. And notice what you get, 0.63. Okay, so this problem here, there were multiple ways of doing this. You could have taken the natural log of both sides, then use the power rule, and then get x by itself. Now remember, the direction says express in terms of natural logarithms or common logarithms. So this would be one of your answers, and then the next part would be to approximate, so it will be the other one. Okay, so here's one of your answers, and the next part will be the approximation. Here's one of your answers, and the next part would be your approximation. Now, the point that I was making with this one is this: if you remember that the log of 10 was 1, then good. You really need to use it. And so x times 1 is x, and so you get this. Then using your calculator, this is what the log of 4.23 is approximated to, was 0.63. 2 decimal places, 0.63. If you did not remember that the log of 10 was 1, it's no big deal. Well, you really should. But it's because there could be situations where you will be expected to remember that. But if you didn't in this case, it's no big deal. You just divide both sides by the log of 10. You get this as your logarithms, and then your approximation is this. Okay. All right. Now the point is this. This is what you really should always remember. If the base is 10, you need to take the common logarithm both sides. If the base is 10, so if the base is 10, take the common logarithm of both sides. All right, so the base is 10, take common logarithm of both sides. And here's why. Make sure you understand why. Because whenever you take the logarithm of both sides, if the base is 10, then this is always going to be a 1. The log of 10 is 1. If this was 100, the log of 100 is 2. If this is 1,000, the log of 1,000 is 3. Because remember, if this is 100, you say 10 to what squared is 100? Well, 10 squared is 100, so you get 2. But this is just 10, so 10 to the first power is 10. So whenever the base is 10, you take the common logarithm of both sides. If the base is e, take the natural logarithm of both sides. Take the natural logarithm of both sides. All right. Now, and the reason for all this is it makes things a little bit easier for you. It makes the expression a little bit easier to deal with, because what's going to happen, remember, the log of 10 is, right here, the log of 10 is 10 to what power is 10? The answer is 1. The natural log of e, or the natural log ln, is really log base e. So e to what power is e? The answer is 1. Okay, so the log of 10 is 1, and the natural log of e is also 1. Okay, all right, and then you would be able to use that in here and make things a little bit easier for you. All right, so let's look at number 2. All right, so number 2, let's suppose we had this in number 2. Suppose we had e to the x equal 5.7. So e to the x equal 5.7. All right. according to what we just talked about, what would be the easiest thing to use? Take the common logarithm both sides or take the natural logarithm both sides? All right, hopefully you said the natural logarithm because this is e. So since this base is e, you want to take the natural logarithm both sides. Now, will you get a different answer if you took the common logarithm both sides? The answer is no. You'll still get the same answer. But the reason you want to use the natural logarithm is because at some point you're going to have the natural log of e, and the natural log of e is 1. So you'll be able to replace the natural log of e with 1. All right, so look at what happens. So there's no acting of the bases be the same, so I'm going to take the natural log of both sides. So you can say the natural log of e to the x equals the natural log of 5.7. Then I'm going to use the power rule. Remember, the whole idea of taking the logarithm of both sides, in this case base e, is to get the variable by itself, to get the variable out of the exponent. So now since I've taken the natural log of both sides, I can use the power rule, so I can pull this variable out in front, and I get x times the natural log of e equals the natural log of 5.7. And then I need for you to remember that the natural log of e is just 1. If you did not remember that, at the next step you would have to divide by the natural log of e, but the whole reason for this rule right here, not a rule, but the suggestion is that if the base is e, take the natural log of both sides, is because of the fact that the natural log of e is 1. And so your factor here is just 1. 1 times x is x, and there's your answer right here. You don't have to do anything else. That's your answer in terms of logarithms. Now let's approximate this. So in terms of approximation, the natural log of 5.7, so natural log 5.7 close equal, into 2 decimal places you get 1.74. All right. Now be aware though that if the directions does not say anything about being specifically in terms of what to use, whether it's base 10 or base e, you could have taken the log of both sides. Okay, nothing wrong with that. You could have taken the log of both sides, but this is the one you really need to use, so you can use the fact that natural log of e is 1, and it makes things a lot easier for you. Your chances of messing up, making some kind of minor error, decreases quite a bit. So if you took the log of both sides, you get the same answer. You'll still get this. Now this will look different, but you'll still get this. And what's what I mean by looking different? See, this is ln. Right now, so this is ln because I took the natural log of both sides. This is common logarithm now. So still using the power rule, so I'm going to get x times the log of e equals the log of 5.7. Now be careful. Do not make the mistake and say this is 1. That's not true. The natural log of e is 1 because remember ln is log base e, so e to what power is e? The answer is 1. Do not make the mistake and say the log of e is 1. That's not true. Okay, not true. It's only 1 if the argument is 1. If the argument is e, the answer is 1 if this is a natural logarithm. So again, don't make the mistake. Don't say this is 1. Okay? That's only 1 if this is natural logarithm. This is not natural logarithm. This is a common logarithm. The bases are different. Okay, so I'm going to go ahead and rewrite this over. And so I'm going to divide both sides by the log of e, just like this. And so the log of e divided by log of e is 1. 1 times x is x. And in terms of the part of the directions that said to express the solution in terms of natural log or common logarithm, then your answer for that part would be just this. That's your answer for that part. Now let's approximate to 2 decimal places. Let's use a calculator. All right, now you got to be careful with the denominator. Okay, so we're going to take the log, we're going to take the common logarithm of 5.7, close the parentheses. All right, so there's your numerator, divide by the logarithm of e. Now remember, we got to get e to the first power, e. So that's going to be, remember that you're going to say second e to the x. Now be careful. All right, so that's why it's a little bit more challenging if you don't take the natural log, because you're going to have to deal with the log of e. And when you deal with the log of e, you have to say log, then it opens up a parentheses, then you have to go second ln to get this, e to the x. And that needs to be a 1 here because I'm looking at e to the first power. Okay, so that's 1. So you can type in 1. Close this. Now be careful, there were 2 open parentheses, so you got to close this other one. And let's see what we get. Oops. Okay, let me go back and delete that part. Okay, now let's enter. And you get 1.74, which is what we said. Okay, so you still get the same answer, 1.74. But notice how you could have made an error in this little part here. So just be careful. Using a calculator, you could have made an error. So it is easier. It is preferable that if the base is e, you use the natural log. You take the natural log of both sides and use the fact that the natural log of e is 1. And 1 times x is x, and there's your answer. Okay? Now, could someone have, just like we did before, could someone have said this? I'll just go ahead and rewrite that part over. So let's say you did not remember that the natural log of e was 1. And let's say you're rushing through this. You shouldn't be rushing, but let's say you were. And you could take the natural log of, you divide both sides by the natural log of e. So the natural log of e divided by the natural log of e is 1. 1 times x is x. Could someone else have used this? Sure. You could have, but it's important that you remember that the natural log of e is 1. Use your calculator, you'll get the same answer. You'll get 1.74. All right? Okay, number 3. All right, number 3. Suppose we had this. Suppose we had 5 to the x equal 17. 5 to the x equals 17. Now, remember, if the base is 10, you're going to take the log of both sides. If the base is e, you're going to take the natural log of both sides. Here, that's not the bases aren't e and the bases aren't 10. So I'm just going to go ahead, rather than doing both of them each time, because you know we'll get the same answer, let's just take the natural log of both sides. So I'm going to take the natural log of both sides. So I'm going to say the natural log of 5 to the x equals the natural log of 17. Remember, the whole purpose was to get the variable by itself. I'm solving for the variable. So I've got to get the variable by itself. Right now the variable is in the exponent, so I've got to remove it out of the exponent. The only way to do that is to take the log of both sides. In this case, the natural logarithm. So now I can remove the variable x. So I get x times the natural log of 5 equals the natural log of 17. And then you got to get x by itself. So what do you think the next step would be? Well, the next step would be, since I'm multiplying by the natural log of 5, the next step would be to divide by the natural log of 5. So the natural log of 5 divided by the natural log of 5, anything divided by itself is 1. 1 times x is x. And then you're left with natural log of 17 divided by the natural log of 5. So that would be your answer in terms of logarithms. Now let's approximate this. On your calculator, you're going to say natural log of 17. So natural log of 17, close the parentheses, divide by the natural log of 5, close the parentheses, and to 2 decimal places, that's 1.76. Okay? Number 4. All right, number 4. Suppose you had this. Suppose you had 5 times e to the x power equal 23. So 5 times e to the x power equal 23. All right, now when we took the log of both sides in this case, and I took the log of both sides, and then right away I rewrote the exponent as a product. So I said x times the natural log of 5. Okay, and then divided both sides by the natural log of 5. Look at this though. This says 5 times e to the x. All right, you don't want to take the natural log of both sides just yet. Okay, you don't want to do that. You don't want to take the natural log of both sides just yet. What you want to do before taking the natural log of both sides is to isolate the exponential expression. So isolate the exponential expression. So in other words, get e to the x by itself. So right now, multiplying by 5, the opposite is to divide both sides by 5. Okay, that's the opposite. And so 5 divided by 5 is 1. 1 times e to the x is e to the x. And so I get e to the x is equal to 23 divided by 5. Okay? So that's where I'm at. So remember, you got to get e to the x by itself. You got to get 2 to the x by itself. You got to get 3 to the x by itself, and so on. So there's a coefficient out here. If it's being multiplied by a number, so if you have a coefficient other than 1, you got to divide both sides by that first. All right. Now I can take the natural log of both sides. Since this is base e, let's take the natural log of both sides. So you're going to just do this. You can say natural log of e to the x, natural log of 23 divided by 5. So that's what this is. The natural log of 23 divided by 5. And so now I can take this variable, rewrite as a product. So I get x, natural log of e, equals the natural log of 23 divided by 5. And then I need for you to know that the natural log of e is 1. 1 times x is x, and there's your answer. Natural log of 23 divided by 5. So that's your answer for x. There's your solution. Now to approximate this, now be a little bit careful. This answer is different than this one in terms of what you put into your calculator. And over here in your calculator, you have to say natural log of 17 divided by the natural log of 5. Here, you're just going to say the natural log of this fraction. So you're going to say natural log of, and then you're going to say 23 divided by 5, just like this, close the parentheses, and equal, and you're done. So that's 1.53. To do decimal places, 1.53. Okay? All right, now, let me just show you something. I'm going to go back and do the same one we just did, number 4, and I want to just remind you about something. Okay, so it's number 4. All right, 5 e to the x equal 23. Now, it is preferable, guys, it is preferable that before you take the log of both sides, or before you take the natural log of both sides, that the exponential expression is by itself. That if it's being multiplied by a number, if it has a coefficient other than 1, then you divide both sides by that coefficient. But let's suppose you said this. Let's suppose, and by the way, the reason for that is it does make this whole solution process easier to deal with. It does make it easier to deal with. You're prone to making fewer mistakes if you remember that you got to get e to the x first. So I'm going to divide both sides by 5. Let's suppose you forgot to do that, that you didn't do that. Okay, that's fine. You would say, well, I'm going to take the natural log of, we'll go ahead and rewrite this. So then you can say I'm going to take the natural log of both sides. And notice I put the 5 e to the x in parentheses. All right, now look at this right here. See, I can't, I remember our discussion from the past, and so that's why that's what makes this difficult to do if you don't forget to divide both sides by 5, because you do have to remember quite a bit from the past. So right now I cannot rewrite this as x times the natural log of 5e. I cannot do that because this whole thing is not being raised to the x power, only the e. So remember our discussion when we did this in a previous lesson. So I have the power rule and also I have the product rule. So which one must I use? I must use the product first. So this becomes the natural log of 5 plus the natural log of e to the x. That's what that becomes. And then that's going to equal the natural log of 23. So notice how much more challenging this becomes if you do not divide both sides by 5 first. All right, now if you leave it as it is, then you're going to take the natural log of both sides still, but you have to deal with something a little bit more complicated. Now we can take this variable, rewrite it. So we get the natural log of 5 plus x natural log of e equals the natural log of 23. Now I want you to remember this, the natural log of e is 1. So I get natural log of 5 plus x equals the natural log of 23. And so to get x by itself, I'm going to subtract natural log of 5 from both sides. Now be careful, notice what's going to happen. When I combine like terms, the natural log of 5 subtract the natural log of 5 is 0. 0 plus x is x, and I get the natural log of 23 minus the natural log of 5. And remember, I can rewrite the difference of the natural logarithms as one natural logarithm. So I can condense this. So you need to condense this. Condense. Remember we did some problems where we had to condense. So when I condense this, it's just a subtraction. I'm going to write this as a quotient. So it'll be the natural log of 23 divided by 5, which is what this is right here. Okay? So it is more challenging to do this if you don't get the get the exponential by itself. So if you don't divide both sides by the coefficient, it is more challenging. Look how challenging this is compared to just this. Okay, all right, so that's number 4. All right, let's look at this one. So let's look at number 5. And number 5, suppose we had this. Suppose we had 3 e to the 5x equal 1,200. Okay, so 3 e to the 5x equals 1,200. Okay, so let's think more strategic. Okay, so what do you think is the more preferable thing to do first? What should I really do first? Okay, well, let me go ahead before I get started, because I don't want this to see, if I divide both sides by 3, which is what we have to do, this becomes 400. So let me make this, I want to leave this as a fraction. So let's make this 1,207. All right, 1,207. So let's make that 1,207. Okay, so to make things a little bit easier for ourselves, we're going to divide both sides by 3. So I'll go ahead and rewrite this over. Divide both sides by 3. 3 is divided out here, and I'm left with e to the 5x equal 1,207 divided by 3. Okay? Alright, now I've got to somehow take this exponent and rewrite it. So I've got to take the log of both sides. Now the base is e, so remember the base is e. It is preferable to take the natural log of both sides. So I'm going to go ahead and rewrite this. 1,207 divided by 3. So I'm going to take the natural log of both sides, just like this. And now I can take this exponent and rewrite it. Okay, take this exponent and rewrite it. So kind of circle it and then use an arrow to indicate you're going to multiply the exponent times the natural log of e. So I get 5x times the natural log of e. Make sure you see that's what you get here. Equals the natural log of 1,207 divided by 3. Now this is where you need to know that the natural log of e is 1. And 1 times 5x is 5x. I get 5x equals the natural log of 1,207 divided by 3. And now one more step and you're almost done. So to get x by itself, right now I'm dividing by 5. I'm multiplying by 5. The opposite would be to divide both sides by 5. So I'm going to divide both sides by 5. And so 5 divided by 5 is 1. So I get x equal, and there's part of your answer right here. So natural log of 1,207 divided by 3. All that's being divided by 5. Okay? Now approximating this, let's see what we get. Okay, so here's what you can do in your calculator. So let's do the numerator first. So I'm going to get the natural log of 1,207 divided by 3, close the parentheses, and then that's being divided by, so they divide by 5, and they press equal, and you get 1.99. So remember how to round this off. So don't say 1.19, because the thousands places 5 are bigger, so this now becomes a 10, which makes this now a 1.20. So this is approximately equal to 1.20. So remember, you do want 2 decimal places, so make sure you put 2 decimal places, so the second digit is a 0. Alright, so that's number 5. Okay, number 6. Suppose you had, alright, let's suppose you had this. The natural, e to the 1 minus 5x equal 793. Okay, so what do you think you would do first? Would you no, before we go on, notice that the coefficient here is a 1. So remember the previous problem, we had to first of all divide both sides by 3. We don't have the situation here because e, the base, is already by itself. See, that's coefficient 1. Okay, so now the next step, though, since the base is e, do I take the common logarithm both sides, or do I take the natural logarithm? Now, it doesn't matter which one, but which is preferable? Which should you use? You should take the natural logarithm both sides. So I'm going to say the natural logarithm of e to the 1 minus 5x equal 793, the natural logarithm of 793. So all I did was I took the natural logarithm both sides, and now I can take that exponent and rewrite as a product. Notice what happens, though. This becomes 1 minus 5x in parentheses times the natural log of e. That's what this is, so make sure you put parentheses here. Because if you don't, you would say this. And mathematically, this means that the only thing that you multiply the natural log of e by is 5x, and that's not true. Okay, so be careful. You need parentheses. Okay? All right. So equals the natural log of 793. Now this is where you got to remember that natural log of e is 1. So you're left with 1 minus 5x equals the natural log of 793. Okay? Now you got to be careful some more. What I would do first, and it really doesn't matter, there are multiple ways of writing this. You could have subtracted 1 from both sides first, because remember you're trying to isolate the variable term. Now be careful. This side is 0. 1 minus 1 is 0, so you're left with negative 5x. If you're not careful, you're going to say that's a natural log of 792 because you're saying 793 subtract 1 is 792. That's not true. That is not true. That would be true if this was just 793, but it's not. Then this is a natural log of 793. The natural log of 793 is not 793. All right, so you cannot say, so don't say, that is wrong to say that that is a natural log of 792. That's wrong. All right, so you can't, these are not like terms. This is remember, logarithms are functions. So this is a natural logarithm 793, and this is just subtract 1. This is just a constant. So they're not like terms. So, well, this is a constant also. The natural log of 793 is a constant, but what I meant was you're not taking the natural log here. So natural log of 793 minus 1. And then finally, the last step is divide both sides by negative 5. I'm going to rewrite this over. So divide by negative 5, divide by negative 5. And so negative 5 divided by negative 5 is 1. 1 times x is x equals, and so there's your answer. Natural log of 793 minus 1 divided by negative 5. And then approximating it, you would say this. Now you got to be careful how you write this, so listen carefully. All right, so you're saying the natural log of 793. Now make sure you close it because that's what you're taking the natural log of. You're taking the natural log of only 793. So make sure you close parentheses. Then say minus 1. Now be careful. If you say divide by negative 5, then what you're saying is that negative 1 is the only thing that's being divided by negative 5, and that's not true. This whole numerator has to be divided by negative 5. So at this point, you need to press the equal sign, and that is your numerator. So this part is your numerator. Make sure you understand that. That's your numerator. And then you take divide by negative 5, and then you get negative 1 point, I can't see it, negative 1.14. Okay, so that's your approximation. So let's discuss this again, how to put this in your calculator. So in your calculator, you're going to say the natural log of 793. You got to close that parentheses, though, just like this. Then you're going to subtract 1. Now be careful. If you say divide, if you say this, if you say divide by negative 5, that is not what this is. What you just see this right here on your calculator, and I'm going to go ahead and write just to show you. On your calculator, what you're saying is this: the natural log of 793 minus 1 divided by negative 5. That's what you're saying. That's what this is right here. And when you press equal, That is the one that's approximated to 6.88. Okay, but that's not what this is. So that's not this. Not this. This is this. So in your calculator, you're going to say natural log of 793, subtract 1, then press enter first, and then say divide by, and then -5, and press enter again. Okay, so you're going to say natural log 793, close the parentheses, I forgot to say close the parentheses, right here, and then subtract 1, press equal, so that's your numerator. Then divide by -5, press equal again, and that's what you get, negative 1.14. Okay? Alright. So that's number 6. Okay, so that, let's do this one. Let's do one more. Alright. Let's do number 7. So number 7, let's suppose we had this. Suppose we had 7 to the 0.3x equal 722. Okay, 722. All right. Now, you remember we took the natural log of both sides in the other problems. Let's just take the common logarithm here. Let's just use the common logarithm. So I'm going to take the log of both sides. So I'm going to let's just go ahead and rewrite this over. All right, leave some space here. So I'm going to take the log of both sides. Now, when I take the log of both sides, you're assuming your base here is 10. So we're taking the common logarithm. We're using the common logarithm. So now I'm going to use my power rule. So we'll pull this out in front. So I get 0.3x times the log of 7 equals the log of 722. And then if you need to do this in steps, what you may want to do first, okay, so what you should do here, see how you're trying to get the variable by itself? And so on this side you're multiplying it by 0.3. On this side you're multiplying by the log of 7. So listen carefully what I'm about to say. Okay, listen carefully to what I'm about to say. Okay, so you remember trying to get x by itself, right? So right now I'll multiply by 0.3. So I'm going to divide by 0.3. Okay? Right. Also, I'm not only multiplying by 0.3 by 3/10, but I'm also multiplying by the log of 7. So I'm going to divide by the log of 7. So notice what happened. So to get the variable by itself, you're going to divide both sides by 0.3 times the log of 7. 0.3 times the log of 7. And now, if you notice, the 0.3's divide out, the log of 7's divide out, and you're left with x. Alright, so be a little bit careful with that one. And so the log of 3's divide out, the log of 7's divide out, and you're left with x. So x equals, and that will be the answer in terms of logarithms. So the log of 722 divided by 0.3 times the log of 7. Now in your calculator, you're going to approximate this, and you've got to be careful when you approximate this. So listen carefully. So there are lots of little rules when using your calculator with some of these things. So let's talk about the numerator for a moment. The numerator, you have the log of 722. So that's no big deal. So you can say log 722, close the parentheses. All right, now this is where you got to be careful. The denominator, when we did the others, when we used a calculator in the others, notice that the denominator was one factor, -5. So I just said divide by -5. Here, the denominator was one factor, 5. So I divided by 5. Here, the denominator was natural log of 5. One factor, the natural log of 5. So I divided by the natural log of 5. The point here is this. This is actually two factors, a factor of 3/10 and a factor of log of 7. So here's what I need for you to understand. If you're not careful, you're going to do this. You're going to say, which this is wrong, you're going to say this. You're going to say the log of 722, close the parentheses, divide by 0.3 times log of 7. Oops. 0.3 times log of 7. All right? So that's what you're probably going to say. You're going to say log of 722 divided by 0.3 times the log of 7. But that's not what this is. This right here is not this. All right, that's not this. Then you're going to say, some of you are going to say this, then some of you are going to say, well, I'm going to say the log of 7 to 22, close the parentheses, then I'm going to divide that by 0.3, and then, oops, I forgot to do division, 0.3, and then I'm going to divide that by log of 7. And close parentheses. And that is okay. That is correct. Okay? So you should get 11.27. So remember, we just did a calculator. In the calculator, you would say this. So calculator, you would say log of 722 divide by 0.3. Then you also divide, so you're doing this, so you did this, then you're also dividing this thing by log of 7. Okay? Now, the other way you could have done it is this on your calculator, and then press enter. The other way you could have done this on your calculator was this, and listen carefully, you could have done this also. So the calculator, so your numerator is a log of 7 to 22, divided, remember there are parentheses here, divide by, now put the denominator in parentheses, so say divide by parentheses 0.3 times the log of 7, close the parentheses. So basically you're saying the numerator, the denominator is a product. All right, so you put the whole thing in parentheses, and then you should get this right here. So let's see. So you get the log of 7 to 22, close the parentheses, divide by parentheses, open parentheses, and then this product, 0.3 times log of 7. Don't forget to close that parentheses for the 7, though. So this is what you really should have, the parentheses there. And then close it again, and then press equal, and you get 11.27, which is what we wanted. Okay, all right. So this was the lesson on solving exponential equations, where you have to take the log of both sides. You have to either take the natural log of both sides, or take the common logarithm of both sides. It doesn't matter which one you use, but if the base is e, you take the natural log of both sides, because the natural log of e is 1. If the base is 10, you take the common logarithm of both sides, because the log of 10 is also 1. Okay? All right, so that concludes this lesson.